Hello, I'm Angela Shetty and I'm here to do part B of your lecture for HSC112 Basics of Epidemiology. And in this part of the presentation, what we're going to do is have a look at the biostatistics side of epidemiology. So going through the learning outcomes for this, we're looking at defining and describing biostatistics and its terms, demonstrating an awareness of the importance and rationale of biostatistics as one of the essential subfields in epidemiology, outlining the key points of the concepts that underpin biostatistics, and demonstrate an understanding of basic biostatistical methods and reasons for their use. Much of this content's addressed in the PDF handout for the unit, and so you'll see that in Module 1. So you should have already been working through that. And we're just going to do a little bit of a supplement of information in this presentation. So I'll just be giving you a little bit more outline on what exactly biostatistics is all about, and a little bit about what it means to be a biostatistician. Okay? To define and describe biostatistics, well, biostatistics is the application of statistics to biological studies. It refers to the numerical data obtained through studies and reciprocally the study of the data. And this all helps direct evidence-based health decisions. We talk about evidence-based health and what we mean by that a little bit further on in the presentation here. But basically, biostatistics covers many areas or disciplines. So we might use it for molecular biology, genetics, agricultural studies, different types of animal research. But in the context of this unit, we're looking at generally its clinical trials on humans and in the field of epidemiology, and generally then to move forward to improve public health. So we see what we might look at to put it into context for you, and I will go on and do this in other slides as well, that it's really looking at different presentations of disease, illness, injury in population groups across Australia for the context of this unit, and then taking all of the data that we get from those studies. So let's say that we're looking at the difference in height and nutrition intake in Indigenous populations of Northern Territory, and we might even have a comparison to non-Indigenous populations, or we might be looking at what the difference is between height of Indigenous people who are living in rural and remote areas in relation to those living in more suburban areas. And so we can go out and we can do lots of measurements. We can take people's height, we can take their weight, we can find out where they live, we can find out, put them into age group ratios, we can put them into the demographic groups. And so there's a lot of information that we can get that we can then rearrange and gather and study to find different points that could basically show us where there might be disparities, differences, where we might need to look deeper and do more research and so forth. So it's the actual statistics, all that numerical data that we're actually looking at in biostatistics that helps us start seeing where we, as I said, where we're going to find disparities in health and what we might be able to then do to address these. So it's a really, really important part of any research in population groups. Okay, so what we can see is that biostatistics is the application of statistics to biology, and it's frequently associated with applications in medicine and also in areas like agriculture, so forth. Our biostatisticians, well, they cover actually many other areas and disciplines as well. And if we're going to get down into the really nitty-gritty of it, I guess we could say, you know, we're looking at things like molecular biology, genetics, animal research, and more in line with what we're looking at within this unit, clinical trials on humans and epidemiology. So biostatisticians have said they analyse the data and statistics and living things collected during their research studies, and they draw conclusions and make predictions. So it's one of the most essential subfields in epidemiology, as we really use our biostatistics to determine how diseases develop and progress and spread. Now, I'm not going to go through and redefine what epidemiology is all about, because that's something that we've already covered in the previous section and class for this unit. But basically, as I've written here, Together, biostatistics used in epidemiology studies helps to establish the frequency of a condition or illness or disease or injury prevalence in a population. So what do epidemiologists and biotechnicians or biostatistic technicians do? Well, epidemiologists study the frequency and distribution of disease within human populations and environments, and biostatisticians develop and apply the statistical methods to scientific research in health-related fields. So epidemiologists basically, as we said, they're looking at the frequency and distribution of disease within human populations and environments as well. In an epidemiological study, the investigators are going to determine if any factor is associated with the health effect. So we might be looking at, say, an outbreak of salmonella, for example. And these ones are quite, unfortunately, happen quite frequently across Australia. Most recently with egg products and eggs from different farm groups, where salmonella was isolated. So we will find the illness within the population. We've got people coming in to see their local doctors and so forth, presenting with a diagnosis of salmonella. What we need to find out is, where is that salmonella coming from? So as epidemiologists, we're going to start taking the stories and studying what's happened to that person, what have they been eating, where have they been, what have they been exposed to, and what other cases of salmonella have come in, to try and link it together so we can actually isolate the actual source of salmonella. So basically epidemiologists then are trying to compare groups of people who are alike except for the risk factors under evaluation. So it's concerned with the patterns of disease occurrence and the factors that influence these patterns. And it's really important in any sort of public health and preventive medicine as well. So our biostatisticians, on the other hand, they're looking more at developing and applying statistical methods to scientific research in health-related fields. And the role of the biostatistician, it's really important, particularly when it comes to designing studies and analysing data from research problems. So they help formulate scientific questions, they will decide what sampling techniques. So if we looked at our outbreaks of salmonella, our biostatisticians are going to help us decide what type of study we might need to do. So we might have one group, for example, who are actually doing the looking at the tests of the salmonella to find out what strain of salmonella it is, because they'll need to isolate that, because once they know the type of salmonella, then they'll have a better idea of where it's going to be coming from. Okay, so they're kind of looking at more of those areas. What do we actually need to infinitely study and question in order to find the answers that we need? And then if we've got a whole heap of our data put forward, a lot of our biostatisticians can then conduct their statistical analysis and go through different research strategies to drag out information that again will give us a lot more ideas of how to control things like outbreaks of salmonella and so forth. So they play a really important role in the preparation of research and also in the preparation of research material for publication, because having someone who's got that ability to work as a biostatistician on a research project means you've got someone who really knows how to design the research project to make sure that the data and the information you're collecting is relevant, that it's going to be analysed properly and so forth. So a really, really interesting area to work, and very broad as well. And so we're looking, epidemiologists, biotechnicians and so forth tend to be hand in hand and working side by side, if not actually having a crossover in their roles. To help put this in perspective a bit more for you and give you an idea of where you might work in the future if you're interested in working in epidemiology or biostatistics, and to go further on in that field, you can start out with your Bachelor of Health Science. You've got this unit here to back you up, and you will be doing another research unit no doubt within your studies at some point. And then normally you'd go on and do a Master's either in Public Health or a Master's of Epidemiology, where biostatisticians would come into that as well. But as epidemiologists and biostatistics, you're going to be performing a lot of research, education. You're going to work in a lot of public health practice. You work across universities, government agencies, international agencies, and quite a lot of private corporations will be taking you on board too, particularly in agricultural areas and so forth. So The epidemiology basically, it covers a lot of specializations, such as the study of infectious disease, the study of chronic disease, and their different incidences and causative factors and so forth within populations. They look at environmental and occupational determinants of disease, and genetics determinants of disease as well. And so we might do really interesting studies, for example, environmental determinants of disease, to find some link between things such as wind farms and higher incidence of cardiac disease. And so that might be a study that's going on that might prove or disprove that there is an association between those two factors, that people who live within close vicinity of the wind farms, which generate power, have higher incidence of cardiac disease. So they might be the types of questions that we'd be asking, and we'd need to go out and collect a lot of statistics, a lot of measurements and information, be able to determine whether that would be so. So that's looking at more of the exposure and so forth as well. So biostatisticians said they're developing and applying their statistical methods to scientific research in health-related top fields. And again, we're working across areas such as medicine, epidemiology, and public health. It's a really important role, as we've outlined, particularly when it comes, as said, to designing studies and analysing results. Looking at examples in practice for biostatistics, we're looking again at studies used to determine how diseases develop, progress, and spread. The example that I've put up here comes from the Department of Health, and it's looking at flu cases by week commencing for the Northern Territory region. And this is actually for this year, okay? So this goes from statistics from January, the beginning of the year, right through to, I think it is June, July this year. And as you can see, there's categories of whereabouts in Darwin the measurements are coming from, such as Alice Springs in the brown colour on this, or we've got Greater Darwin region in the blue colour, for example. So what this table tells us is that we can see that we had a fairly high incidence of flu actually very early in the year, which is unusual. Okay, and particularly around the Greater Darwin and Katherine regions, and even right through to West Arnhem and Tiwi Islands. That all sort of decreased again for a little while through February, March, and then as we hit April, May, we've got a really big peak, particularly in the Alice Springs region. And so all this data has come from samples and so forth collected by local doctors, blood tests and so forth, that they can start putting together and start seeing a picture of how the epidemic of the flu is spreading across Darwin region, which areas are being hit more highly, which areas tend to be not hit so highly at a period. And again, it might let us see that, okay, if we've got a lot happening in the Alice Springs district and not so much happening in the outer Alice Springs area, that we might start targeting those areas, because we can see that it's probably going to spread to those areas next. All right, and so that helps us, you know, see how the progress and the spread of the disease has the potential to go, and we can move ahead and start making sure that people in those other areas are vaccinated against the flu, particularly those people who'd be at greater risk. So it's really good to predict the behaviour of an illness like the flu. It's also we can use biostatistics to help predict mortality rates, to help predict what time of the year people might be more likely to get the flu, because we can, you know, start keeping these tables over a series of years and see where the trends are coming in. And we might use it to sort of see how the effectiveness of vaccination and so forth is all going. So a lot of really interesting and very, very significant work can result from what our biostatistics and our epidemiologists can be doing out there. I mean, today, like the epidemiology, I guess we're seeing a lot of investigation around infectious disease outbreaks, but it's also becoming more and more concerned with our chronic disease. So we're seeing a lot of epidemiology studies looking at heart disease, cancer, and stroke. And certainly we're also looking at other areas such as injury and suicide rates and so forth. And again, we're sort of studying how that's all affecting different populations, and what we can be doing to try and reduce the impacts of those, or actually reduce it from occurring in the first place. So putting a lot of information in towards preventative studies. So I guess, you know, in the greater picture of things, we might not actually realise how important studies around epidemiology and certainly around biostatistics is important for us, and how how significant its contribution is to keeping populations healthy. But when you look at in practice, and we look at the results we've had with things like polio vaccinations, and there would have been a lot of biostatistical research done around that in looking at how the vaccination was working, who were the populations that need to be targeted, what was the predicted outcome, and what was actually happening with people who were being vaccinated, to the point now that Australia is polio free. And so it's a work, not just by the medical and the nursing profession that are out there who are educating the people and giving them vaccinations, but by these people who are in the background doing all of this research to see, is it actually having impact? Are we actually making our populations healthier? So, as I said, a great area to think about moving forward in. And as you progress through your studies now, whether it be in, gosh, we've got a real mix in this unit, whether it be in nursing or health science or sports science or what have you, that you'll start understanding a lot of the information that you might be reading has that level of biostatistical input in the background to help make sure that the health data was good, that the health study design was good, and that the questions and the direction the research was taking to give us the final results was all evidence-based and well done. I don't want to go into too much depth about the statistical methods. This is very well covered in both the information that's provided within the PDF readings and the other readings that you're directed to within Module 1. But you do need to be very familiar with is the fact that there's two major branches, okay, for statistical methods, and that's our descriptive statistics, which explains the distribution of population measurements by providing types of data, the estimates of central tendency, and measurements of variability, okay, whereas our inferential statistics, the second branch, is used to express the level of certainty about estimates and includes hypothesis testing, standard error of mean, and confidence interval. Now, when we look at, we break this down into more different types of data, okay, and we'll go on and basically have a quick look at those. But I guess, we need to realise that the statistical methods they're important to draw valid conclusions from the data that we get, and it's basically a way of thinking about the data and how we can use it. So we like to do a lot of analysis. We like to look at a lot of measurements, okay, of the data. We look at perimeters of the data, meaning where has it been collected, over what time has it been collected, what exactly are the measurements that we're using within that, and they're all really helpful in analysing different types of observations, and it helps us look at hypotheses. So when we're doing a hypothesis testing, it's saying that we have a question and so forth that we want to find out if it's going to be true or not, and so that might be that the flu vaccination is going to effectively protect people from the flu in 2019, and so we'll start looking at how many flu vaccinations we're giving out, where we're giving them out, and where the incidence of flu is happening, and are people who are having vaccinations getting the flu, and if they are, what strain flu it is, and that goes down to that really infinite means of biostatistics in looking at strains of flu and what strains of flu the flu vaccination is aiming for, and so forth. And so that all falls in to whether it's going to be descriptive statistics or inferential statistics. Within biostatistics, there's generally 4 types of data that we refer to: nominal, ordinal, interval, and ratio. And if we start to break them down and have a look at them individually, it becomes quite evident that there's an obvious difference between the different types of data that we're going to be collecting and how we would then analyse it. So our nominal data is data that can be separated into discrete categories which don't overlap. So that's where we might have 2 groups, such as male, female, 2 separate groups. They're not going to overlap. It might be eye colour, for example. We've got a group with blue eye colour, a group with brown eye colour. and so forth. Ordinal data is data that's collected and scaled. So the example we've given you here is we might have a happiness rating on a scale of 1 to 10. Another one that we might use quite a lot in health is pain scales, where again, we'd be asking someone to rate their pain on a scale of 1 to 10. 10 being the worst pain imaginable, 0 being no pain. And that ordinal data helps us gauge how much pain that person's in and then respond accordingly. We've got our interval data, which comes in sort of numerical values. So that means we might be actually looking at the difference between points. So we might be looking at the difference, the impact of a temperature between 20 and 30 degrees, for example, has on a factor. So we're looking at that interval data there. Okay. Again, we might look at it as weight, or for example, blood pressure readings, where we take a selection from here, from someone who has a systolic blood pressure, for example, of 80 up to 110 and so forth. And that would be our interval data that we'll be working with. And our ratio data is very much like our interval data, and we've got the numerical values where the difference between points is standardized and meaningful. So what we might do is, like, we'll have ratio data. For example, we might measure height in centimeters, meters, inches, or feet, and when comparing temperature, it would be the same. That would consider the difference between the ratio of height at this level as compared to in feet to centimeters and so forth. So you can find more out about the different types of data within your readings in Module 1. And we've given you quite a few directions there, and I've also put together an online quiz for you just to help practice some of the new terminologies that you come across. I think that can be sometimes the hardest thing when you start learning about areas such as epidemiology and biostatistics, is it almost feels like learning a bit of a new language. So just getting back to, though, the importance of evidence-based public health practice. And I guess, the reason I've gone and put this slide back in here is because it's really, evidence-based practice is the foundations of everything that we do within our health practice. That we must make sure that we're making the decisions based on the best available scientific evidence. So we're not just making assumptions about things, we're actually making informed decisions about how to move forward. And that we're looking at scientific evidence that has systematic use of data and information settings. And again, it's where it's so important that we have studies in epidemiology and biostatistics coming in to inform that systematic use of data. And then we can use all of this information and statistics that we've found to apply program planning and frameworks. And that leads on to then engaging the community in decision making and conducting sound evaluation and disseminating what is learned. So it all starts from the very bottom, doesn't it? That we've got a lot of this research going on out there around the health of populations, around disease processes, around what's causing more injuries. And I mean, we've covered it before, such as looking at motor vehicle accidents, and it was found, by bringing in the use of seatbelts, we significantly reduce the number of deaths in road trauma. And so all of that goes through population studies, and that evidence to show that the seatbelts have had an impact in reducing deaths in car accidents is then what can then be used forward to present and develop really good health policies. So now if you don't wear your seatbelt, you actually cop a big fine. So, and that, as you can see, the idea with the seatbelt is that we've got all of that research that's been done in the background, and that's being used in program planning frameworks and developing policy and so forth, and then engaging the community in that decision making and moving forward with that. And so then we've gone back and we'll do evaluation. So we'd have a look now. We've introduced seatbelt wearing. What can we compare with our data now compared to, say, 50 years ago when seatbelts weren't mandatory and so forth in vehicles?